Hello everyone. Today we will learn about the no-load operation and the load operation of synchronous generators. 1. No-load operation. This refers to the synchronous generator being driven by the prime mover to synchronous speed. The rotor excitation winding being supplied with direct current excitation, the stator windings being open-circuited, and the stator winding current being zero during operation. When no load, the internal electromagnetic relationship of the generator is such that the rotor excitation current IF establishes the excitation magnetomotive force FF establishes the no-load main flux phi0. The stator's three-phase symmetrical windings generate three-phase symmetrical no-load voltages E0A, E0B, E0C, and the stator current I is equal to 0. During no-load operation, the air gap magnetic field is solely established by the rotor's excitation magnetomotive force. The strength of the magnetic field is determined solely by the magnitude of the excitation currents. When a synchronous generator operates without load, the no-load magnetic field rotates with the rotor, and its main flux cuts through the stator windings in the stator windings, inducing a three-phase fundamental electromotive force with a frequency of F. Its effective value is E0 equals 4.44 Fn1 times Kw1 times phi0, where phi0 is the fundamental flux per pole. N1 is the number of series turns per phase of the stator winding, and Kw1 is the winding factor of the fundamental electromotive force. 2. Symmetrical load operation of synchronous generators. When under symmetrical load, the internal electromagnetic relationship of the generator is such that the rotor excitation current IF establishes the excitation magnetomotive force FF, establishes the no-load main flux phi0, the stator's three-phase symmetrical windings induce three-phase symmetrical no-load voltages E0A, E0B, E0C, generate three-phase symmetrical currents IA, IB, IC, produce the armature magnetomotive force FA, and produce the armature flux phi10. The main flux phi10 plus the armature flux phi1A establish the main flux phi1 when loaded. The armature magnetomotive force FA and the excitation magnetomotive force FF have the same direction of rotation and the same speed, and are stationary relative to each other in space, thus becoming synchronous. When operating without load, the stator windings are open-circuited, and the stator winding current is zero. When no load, the main flux is established solely by the rotor, and the strength of the magnetic field is determined by the magnitude of the excitation current. When operating under symmetrical load, the stator armature magneto-motive force Fa and the rotor excitation magneto-motive force Ff jointly establish the main flux. The concept of armature reaction when a synchronous generator operates under symmetrical load. The influence of the armature magneto-motive force Fa on the excitation magneto-motive force Ff. The fundamental armature magneto-motive force of the stator windings and the fundamental excitation magneto-motive force of the rotor have the same speed, direction of rotation, and a number of pulses, and are stationary relative to each other. Therefore, the combined magneto-motive force of the two will be a rotating magneto-motive force with the same direction of rotation, speed, and number of pulses. Their combination produces the air-gap magnetic field in the machine. Exercise 1. Characteristics of the internal magnetic field during no load and the load operation of a synchronous generator. Answer. When operating without load, the stator windings are open-circuited, and the stator winding current is zero. When no load, the main flux is established solely by the rotor, and the strength of the magnetic field is determined by the magnitude of the excitation current. When operating under symmetrical load, the stator armature magneto-motive force Fa and the rotor excitation magneto-motive force Ff jointly establish the main flux. In this lesson, we introduced the electromagnetic relationship during no load and load operation of synchronous generators. I hope everyone practices more after class to consolidate the knowledge from this lesson. That's all for this lesson. Thank you, everyone.